Section 1-3 is entitled Solving Equations. So algebraic expressions can be written as verbal expressions and vice versa. So in other words, I can take an algebraic expression and turn it into words, or I can take words and turn it into an algebraic expression, which is going to be something with letters, variables, and numbers and operations. Equations can also be written as verbal sentences, and verbal sentences can be written as equations. Remember, the difference between an expression and an equation is an equation is going to have an equal sign in it. So, first example, write an algebraic expression for the square of a number decreased by the product of 5 and the number. So in other words, I need to take these words and turn it into an expression that has a variable and some numbers and some operations in it. So, the square of a number, and it says the product of 5 and the number. That's my variable. I can choose whatever I want as my variable. I kind of like x. So the square of a number. The square of a number is going to be x squared. Decreased by is subtraction. The product means multiplication. The product of 5 and the number, that's going to be 5 times the same number, which is x. So my final answer as an algebraic expression is x squared minus 5x. Write a verbal sentence for this equation. 7x minus 2 equals 19. And you may not realize it, but an equation actually is a sentence because it does have a subject, a verb, and a predicate. And in fact, I pretty much said that by reading this. 7x minus 2 equals 19. Now, I can't, though, just say 7x because that doesn't really describe exactly what's going on between the 7 and x. I know it's multiplication, so I have to use a word that talks about multiplication. So, a lot of different ways I could do this, but I'm going to do the simplest first. 7 times x. And if you're starting your sentence with a number, actually write it out, please. 7 times x minus 2 equals 19. And put a period at the end because that is a sentence. Other ways I could have done this. The product of 7 and x decreased by 2 is the same as 19, and actually lots of other ways, but sometimes it's just best to do the simplest. Here are some properties of equality. Notice that all of these have equal signs in them. That's why they're called properties of equality. And the first 4 you should recognize from geometry. The reflexive, symmetric, transitive, and substitution properties we used quite a bit in proofs. The reflexive property says A equals A. Anything is equal to itself. Symmetric property. If A equals B, then B equals A. So do you see a certain symmetry there? We have an AB and then a BA. This is sometimes gets confused with the commutative property, but notice there's no, because the letters are rearranged, but there's no addition or multiplication going on here. The transitive property. If A equals B and B equals C, then A equals C. Substitution property, if A equals B, then B can replace A. Wherever I see an A in the problem, I can go ahead and put a B in there. Addition and subtraction properties. If A equals B, then A plus C equals B plus C, and A minus C equals B minus C. In other words, I can add the same thing to both sides of an equation, and it remains true, or I can subtract the same thing from both sides of an equation, and it remains true. Multiplication and division properties. If A equals B, then A times C equals B times C, and A divided by C equals B divided by C as long as C is not equal to 0, because remember, thou shalt not divide by 0. Similar to addition and subtraction, in other words, I can multiply both sides of the equation by the same thing and it remains true, or I can divide both sides of an equation by the same thing as long as it's not 0 and it remains true. So let's take a couple opportunities here to identify each property. Number 1, 3x minus 7 equals 3x minus 7. Same thing on both sides of the equal sign, so that would be the reflexive property. Number 2, if x equals 5, then 2x equals 2 times 5. Looks like what I did in the second part of this was substitute a 5 for the x, and as long as x and 5 are the same thing, I can indeed do that, so that is the substitution property. And if 1/6 x equals 3, then 1/6 x times 6 equals 3 times 6. In other words, I multiplied both sides of the equation by 6. That would be the multiplication property. It doesn't change the equation, I just multiplied both sides by 6. So let's solve a few equations, if you remember some of this from Algebra 1. The main idea here is to get x all by itself, figure out what number does x stand for, and to do that I'm going to undo backwards whatever is done to x. So I'm going to start the furthest away from x. So I have negative 6x minus 8 equals 16. So I'm going to start by adding an 8 to both sides. So negative 6x equals 24. Basically what we used here was the addition property because I added the same thing to both sides to get rid of that minus 8. Divide both sides by negative 6. That's the division property. I can divide both sides by the same number. And x is going to equal negative 4. I'm not going to require it, but if you'd like to, you can check this by plugging in negative 4 for x into the original equation, and both sides of the equal sign should be the same. This example has some parentheses in it, so I'm going to need to use the distributive property. So let's get rid of the parentheses first and distribute a negative 4. So that's going to give me negative 12x plus 40. And distribute a negative 6. That's going to give me a positive 42x plus 36 equals negative 74. Before we start adding and subtracting on both sides, let's combine like terms. Negative 12x plus 42x is going to give me a 30x. And 40 plus 36 is going to give me a 76. And that's equal to negative 74. Let's subtract 76 on both sides. So 30x equals a negative 150. And dividing both sides by 30. X equals a negative 5. If you don't have to write out all of these steps like the minus 76 on both sides, you don't have to. If you can do that in your head, that's quite all right. Number 3. Oh, yay, we get to do some fractions here. And I don't have anything to distribute. I don't have any like terms to combine. So basically I'm going to get all my x's on one side and all of my terms without x's on the other side. So I think I'll start by adding a 1/3 on each side. What that's going to do is get rid of that. And then maybe I will subtract a 2/3 x on both sides. And that will get rid of those. So what I'm going to have over here, and because this is fractions and might look a little scary, I'm going to go ahead and write it out. So I have 3/4 x minus 2/3 x. Notice I have both terms with x on the left of the equal sign. And then over here I have 1/5 plus 1/3. Okay, let's go to common denominator land. Do you remember how to do this? I'm going to, on the left side, my common denominator is going to be a 12. So that's going to give me multiplying by 3, 9/12 x, and multiplying by 4, 8/12 x. And my common denominator on the right is going to be 15, multiplying by 3, 3/15, and multiplying by 5, 5/15. That's going to leave me with 1/12 x equals 8/15. Multiply both sides by 12/1. And that's going to leave me with x equals, let's divide both of those by 3. That's going to leave me with 32/5. And that is the right answer. It looks a little weird. If you would like to, you can actually plug that back in, and if you'd like, I can show you how to do that on the calculator. Come see me outside of class. So now we need to solve each equation for the specified variable. In other words, I need to write this equation in terms of just one variable. So 8x minus 5y equals 3. I have to solve it for y. I need my final answer to be y equals everything else. So I need to get y all by itself on the left side of the equal sign. To do that, I'm going to start by subtracting 8x on both sides. And I'm not really solving. I'm not going to get y equals 6 or y equals negative 3. I just need to have a y on one side all by itself. 3 minus negative 8. Or you could write that as negative 8 plus 3. Now if I divide both sides by 5, negative 5. It's not actually going in very nicely, so I'm just going to leave it like that. So y is equal to 3 minus 8x all over 5. Or if you switched it around, you could say y equals negative 8x plus 3 over 5. But this is okay like this. And our last example here. X plus y over z minus a equals b. And I need to solve that for y. So I need the y that's on top of the fraction that's having a subtracted from it. I need that all by itself. First thing I want to do is move this a to the other side. So that's going to leave me x plus y over z equals a plus b. I kind of like to put them in alphabetical order. Let's multiply both sides by z. And that'll cancel those out. So x plus y equals z times a plus b. And to get y by itself, I need to subtract an x. So y equals z times a plus b minus x. It's not pretty, but that's what the answer is. Y equals z times the quantity a plus b minus x.